evening. Yeah, I hope so. Hi, good evening, everyone. Thank you for staying on the first day. I know you're all tired. And I'm the only thing standing between you and dinner. Yeah? So we're going to have a quick chat. If all of you could please quiet down, if you must talk, you are welcome to step out. It's very hard for me to talk, but there's a buzz in the room. Okay? Alright. So we're going to talk about scientific writing and publishing. There are two core topics I intended to cover today in the hour-long session, but I want to shorten it also to let you go on time. Well, not so much on time, but sort of on time. Yeah. So we try to wrap it up in 45 minutes. So I'm going to give you a choice. I have two core topics I want to cover today, but I will cover only one of them. The two topics were publishing and research ethics, and the other topic was paper structure. Which one do you want to cover?
Both are important.
How many for ethics? Raise your hand. Nobody. Nobody cares about ethics. How many for paper structure? Good. So let's then go straight to paper structure. This is very easy for me. Oh, by the way, let me just tell you a little bit while I switch the slides over. Let me tell you a little bit about what I do at Springer Nature, because I'm talking to you here. So I'm the editorial director for Applied Sciences and Engineering in the Asia Pacific, Middle East and Africa region. Now I deal with books and proceedings, so I publish every year the proceedings of HWWE and related conferences. If you go to ICORD, also with the other design conferences. I also have here with me Ritika, who some of you might have met. She's at the Springer booth near
Yes.
the registration desk. And we publish in my team about 500 odd books and proceedings every year from all over Asia. And we also do a lot of workshops. I myself go by reviews experience. And we are seeing a lot of papers. So 40% of what my Asia team publishes every year is proceedings. So we see literally tens of thousands of proceedings articles in and out coming through our desks every year. Okay? So I'm going to tell you something, one based on the general knowledge that's available out there, which you also have access to. So there's nothing that I'm going to tell you which is out there about paper structure. Okay, I'm just going to give you tips and tricks to make paper better. Okay? And before I start talking about the paper structure, I have to talk about the structure of your study or the design of your study. Okay? So, those of you who are doing a PhD or have just finished your PhD, how many of you went through a research methodology course before you started your PhD?
Research.
Okay, that's good. Anyone who didn't go through a research methodology course? Recently, I'm talking about the last 5 to 10 years. Everyone did. Okay, great. Because we are still very varied in this country about where the course gets taught and where it doesn't get taught. Yeah? So I'm hard at it. Okay. There's another gentleman in the back also who's on the phone. If you need to speak on the phone, please step out. So we are going to start talking a little bit about study design. You have seen this before, yeah? You've been taught how to design your study. But the papers that we see, as I said, we see tens of thousands of papers come in every year through our desks. And I've also been running the journals program in the past and saw a similar thing. The papers that we see from the subcontinent, from this region, we often see that the study design, even though you've been taught about it, you know about it, it's not implemented in practice. Okay? Why is the study design important? It actually guides everything that you do related to your research problem and the outcomes that you report after that. Okay? So study design is extremely important. If you haven't been through this exercise yet, some of you might already be working on a research hypothesis, but you don't have a structured study design. I would suggest you go back from this conference and do this exercise. You have to create a study design or a problem design, experiment design, whatever you want to call it, depending on your discipline. It has to first ask the research question. Research is made to progress the field or the state of knowledge in the field. Yeah? So what is it that you are doing to progress? And how do you progress the field, make progress in the field? You resolve unresolved problems. You answer unanswered questions. You bridge gaps in knowledge. Okay? So if you have not identified the problem and structured it properly, it will cause you problems throughout your study. And this is not only for PhD scholars and postdocs. It's for every researcher ever. This study design is exactly also the structure of the format you're asked to fill out when you ask for funding. Yeah? So study design is critical and important. I'm sure many of you are taking pictures, you got the slides, but I'm going to send you the slides as well. And those of you who have been to previous iPods or HWWs probably already have access to the base slide structure. But we'll send it to you anyhow. Okay? The aim today is for me to not so much talk about the slides, I'll run the slides, but listen to what I'm saying. I'll send you the slides, you will feel free to take pictures if you want, but I'll also send you the slides so it's better to probably take them from the source. And also ask questions, okay? So that you can gain the most out of this 40-45 minutes that we have together. Okay. So I'm not going to go through each of those elements because most of you said you have been through a study design course. Do you have questions about any of the elements of study design? Okay. Now I have a question. How many of you have a formally structured study design written down? Okay. Okay. 2 in a room of 40 people. You need to do that, yeah? And remember, every element of your study design is flexible. It will evolve throughout your work. Okay? But the research hypothesis. If the research hypothesis changes, everything changes. Then you have to go back to the drawing board. Okay? So I'm going to step over to the structure of the paper. So the most papers that we publish in in applied fields or even any pure data-based field. What do I mean by data-based fields? Even humanities and social sciences like economics, sociology, anthropology, anything that's reporting data or outcomes, okay, from your study. What is different? Do you want to guess what fields could be different, where the paper structure may not be the same in some cases? Some fields of the humanities like history, literature,
Methods.
Yeah?
Methods.
Sorry?
Methods will be different.
Methods can be different, but in some cases the whole structure of the study is different.
Okay.
Yeah? Some in fields like critical literature, critical
Languages.
languages, literature, languages, it could be linguistics, literature, philosophy, so fields of the humanities. Yeah? The structure is a little bit different. But for the most part, most database studies and database subjects use this structure which you see on the screen to score the expanded in RAD model. The name comes from the names of the four core sections: introduction, methods, results, and discussion. Expanded because it also has all these extra little elements like title, abstract, keywords, and so on. Now the most important part, as I said, this is something you all know. Yeah? What is the new thing that I'm telling you? The new thing is that new picture you see there. Yeah? Storytelling is very important. And why is, I can tell you that there are problems in the way papers are written in this region. What is the problem in this region? In this region, if you are doing, let's leave out those of you because we are looking at a very interdisciplinary crowd here. Those of you who are more on the humanities, I'm not talking about you. But those who are doing the sciences are not expected to do anything else. Okay? Just focus on the math, just focus on the science, just focus on the graphs. And what falls by the wayside is actual skills of storytelling. Okay? You can be great at math, you can be great at science, but if you're not able to communicate what you're doing to an audience, it becomes difficult. Anyone here watches Big Bang Theory? Yes? Okay, you know who I'm talking about? Yes. Yeah? He did win the Nobel Prize in the end. Yeah, but he needed, somebody to come who helped him with communication. Yes, so it's very important that you need to not only be brilliant at what you're doing in terms of research, you also need to be very good at communicating it to your research community. Because those are the people that are reading and evaluating the research. There are also the people who are reading and citing your research. And when do they cite? When they find value. When they find your work useful to promote the research that they are doing. Okay? So storytelling is a very important aspect that we are not often taught as scientists and researchers, unfortunately. It's changing now, but that has been the case in this part of the world, in the subcontinent. You need to, no matter what you are communicating, you need to tell the full story. You could be writing a report, you could be writing a letter, you could be writing a paper or a text message to your mom. The story has to be complete. And nowhere is it truer than in the last case. If you tell your mother that I am going to State Water Conference dinner and I'll come home at 11, those of you who live locally, there are many questions. What conference, what dinner, where, who are you with, who's going to drop you home, right? How are you coming, getting back? Yeah? All of those questions have to be answered. So even a text message requires all that information. So imagine what kind of information we need to tell in the story of our research. So at the back, can you please not talk here, please? Excuse me? Can you please not talk here? I'm getting a lot of feedback from the conversation going around the room. Okay, getting back to our discussion. See, that's what happens. My train of thought gets lost when people start talking. Getting back to our storytelling. So what are we going to do today? We're going to look at each of these little sections, the four core sections, and even the little ones, and see how to make them come out the best so that our story is complete and it's told in a way that other researchers, including our peer reviewers and the readers who read your work, will understand and appreciate and use in their research. Right? Because your aim is not only to get the paper through, you also want citations at the end of it. And you don't get citations unless people find your work useful. So let's start with how to structure your writing plan. Ideally, the methods and the results sections should be written in the at the time that you are doing the research. Yeah? As much detail as possible. You can edit out the sections later, but write them with as much detail as possible. If you are doing experimental work or data collection work, save your raw data. Okay. I always give this example, and I'm not making this up. Okay? I sometimes teach PhD scholars at different institutes, and there was this one case at one of the IITs, and I was teaching these students for some length of time. And one of the students submitted a paper, which was the last one he needed for his PhD thesis to be submitted. And the reviewers came back and asked for a different interpretation of the data. Okay? So what is a different interpretation? To give you an example, if he had, for example, plotted the data against time, they said now no, plot it against the log of time or something like that. Right? So he needed the raw data to make a different visual representation that the reviewers wanted to see. So they wanted, at that point of time, he couldn't find his raw data. He had put it on a hard disk and he had lost it. So this is a while back, maybe 7 or 8 years back. So clouds were not that cloud storage was not that prevalent. And this student used to work in concrete technology. Now, those of you who work and study in engineering schools, you know your colleagues on the civil engineering construction side, you might see them curing concrete blocks for months, sometimes years to do experiments on that. So all of the data that he lost, he had to spend 6 months redoing part of his experiment to pull that data out again. Okay? So you have to be very careful to save your raw data. Reviewers can ask for raw data. Reviewers can ask for different representations of data. And sometimes you might yourself find your raw data useful. 5 or 6 or 10 years down the line, you might be like, oh, that data that I had from that experiment can actually be used here. Also, there are data sharing platforms. So please use those platforms. If your institute allows sharing of data, then use those for raw data sharing. Many publishers also offer platforms for sharing your raw data. Okay? That's what we call the open science movement. Then we come to the next part of the writing. The introduction and the discussion sections should be written only after you have selected your target journal, because journals will have often guidelines on how they want a certain section written. Especially some of the older legacy journals, they have very clear guidelines on how they want something to be written. And once your paper or your first draft is complete, that's when you start building your abstract and writing. Okay? In conferences, it's different. Yeah? In conferences, I didn't know you were here. Good to see you. So in conferences, you are required to submit an abstract, but you usually have an idea, a rough idea of what you're going to submit, and you typically have the methods and the results done when you're submitting a conference abstract. And a conference paper is usually shorter. Yeah? But for a journal article, you always finalize the abstract and the title at the end. They are like the advertisements for your paper. So if your paper is a product, your title and abstract are like advertisements. So you only finalize them when you have the product or the prototype. This is the first one. Okay. Then we move on. Then we move on to look at what a good title should look like. Yeah? A title should ideally be short, concise, and clearly state what was investigated, what was measured, and the sample the measurements were taken from. Now, it doesn't have to be a real sample. A sample for research could be something as simple as a data set. It could be something as simple as survey data. It could be a simulation. It could also be the whole universe. For example, in experimental physics papers that are published around astronomy or particle physics. Now, there are 3 things you should avoid completely when composing a title. Asking a question in the title, describing a methodology in a lot of detail, and abbreviations and acronyms. Now, I'm going to give you an example of an abbreviation or acronym, and I want you to think what it means to you. Do not say it out loud. Don't whisper it to your neighbor. Just think in your head what it means to you, and we will come back to it in a bit. Okay? The acronym or abbreviation is IT. IT. Yeah? IT. Got it? So, once we move on to the let's move on to an example. Before we move on to the abstract, let's see an example. What you see in the top box here is an actual title submitted by the authors of a paper. Okay? And it looks like an abstract. It is, I can tell you, it is in the field of geology. None of us are here are geologists, I can safely say that. But even then, I have actually done this with a group full of geologists. Even they could not figure out what was meant by the first title in the top box. Then you rewrite that title, and when you look at the second title, which is rewritten by an expert, and you see, even though we are not experts in geology, we can make out at least what is going on broadly in the paper. Yeah? That's the difference a concise title can make. And here, in this title, we see that the sample, that the measurements were taken from. Please, can you please step out if you need to speak up? Thank you. The sample that the measurements were taken from is a whole geographical feature in New Zealand. Yeah? The sample. Anyway. Then we move on to the abstract. Typically, you are asked to write a 150-word structured abstract in both conferences and in journals. The easiest way, the cheat code to writing a good structured abstract is use the IMRAN model. One line of introduction, one line describing your methodology, in primary methodology. Third line describing. Now, many of you would be like, we don't even write abstracts anymore. ChatGPT writes now. That's a whole other 1 hour presentation. Okay, then we come to keywords. Keywords are also part of the advertisements for your paper. Why do I keep calling them that? All these open elements, the abstract, the title, the keywords, they're all used to optimize the search engine functioning. So search engine optimization tools. So people who are interested in your paper can find your paper. Okay? So you have to make them as close to the work inside your paper as possible. Keywords, if they are too generic, here in the top box you see a title of a paper. Second box shows keywords that were submitted with that title. Third box shows keywords that were revised by an expert. Okay? So, none of you work in this field, but still, ask yourself very generically, as people who understand English to some extent, we can ask ourselves. But if I were to find, if I was looking for paper on carbon nanotubes, when I search for keywords like molecules, laser, energy, will I? No. What will I search for? And those should be your keywords. Yeah? Ideally, keywords should be phrases which occur, technical terms that occur inside the body of your paper. It's okay to have phrases instead of single words. Actually, it's preferred because it makes them more specific. Okay? Now, before I go to the next section, I will come back to our abbreviation problem. Okay? So, no abbreviations in the title or abstract. But why? So, let me demonstrate with an example. What does IT mean to you?
Information technology.
Information technology. Anyone else? Okay. There is a very glaring one which nobody is mentioning.
Income tax.
Thank you very much. Usually I'm looking at the first row because the row really has students on the back and income tax in the front, and then the United Information Technology from the back and income tax from the front. So it is income tax and information technology are both IT. Yeah, they mean different things in different fields. In my office, they mean different things in a space of 100 meters, depending on which department I'm working. So it's important to understand why we don't want to use abbreviation and acronyms. They can mean different things to people in different fields. So avoid acronyms and abbreviations in your title, abstract, and keywords because they might have other meanings. Yeah? In the paper it's fine, define it the first time, use it throughout the paper, it's perfectly okay, but in the title and abstract, avoid it. Unless it's something very, very common, like DNA, okay, or USA. What does DNA stand for?
Deoxyribonucleic.
Very good. Everyone remembers middle school biology. Oh, now I want to tell you everything I'm telling you today, you can forget. Okay? You are going to forget. But there are two slides I want you to take away. Okay? They will remind you of what I told you. One is this. Okay? This slide maps out the four core sections, four core questions. I told you I'm not going to teach you rocket science today. I'm going to give you little tips and tricks. Okay, that will make the Chandrayaan land. Yeah. So we're just going to talk about the four core questions now. What are the questions? The introduction asks, why are you doing this study? Okay, remember I kept talking about research methodology? It's the same mapping, exactly same mapping of the four steps we saw there. Right? Why do you do the study? Your research question. Research problem, hypothesis, whatever you want to call it. How did you go about it? You describe your methodology and your sample and your measurements, everything to your audience. What did you find in the study? That's your results. And so what does it mean to the community or to the field? How does it make an impact on the field? How does it grow the field? Or even if it's a negative result, it gives some information that how a problem should not be solved. Yeah? So what does it mean for the field? So these are your four core questions related to the four core sections. When you're writing, you need to ask yourself after reading every section, have I answered the question? Yeah? It's very important. If you haven't, you need to go back and revise it. Now we come to each of these sections. Before I start, I want to tell you, I just told you we see tens of thousands of papers coming in every year. Often from the papers from the region, what do we see? There is a paper, half of which, or more than half of which, is a literature review. Okay? Then there is a method section, which is usually the best written section. Then there is results. We found this, these are the figures, the nice figures. And the conclusion, there's no discussion. There is no discussion about discussion also. The conclusion usually is what is reported in 2 to 3 lines. We did this experiment or this study or this simulation and we got the results. Why, how, what does it mean? No reporting on that. The first thing that we need to look at is the introduction section. Now you have limited number of pages or limited number of words in a paper. You want to spend most of it reporting what you are doing, not reporting what somebody else has already done. And that which you are reporting in your literature review, an expert has probably reported 1,000 times better in a professional review paper. Okay? So it's very important that you use the space wisely to report on the work that you have done and how it helps broaden the scope of knowledge in the field. In the introduction, start with a broad scope, identify the problem. Often the problem is completely missing. Okay? Or the problem has been assumed to exist. And the report is entirely about what X, Y, Z and ABC have done to solve the problem. Okay? But nobody understands from that literature review what exactly the problem is. So it's very important to identify the problem. Okay? Limit the literature review. Give your audience a broad scope view. Cite review articles written by experts. Okay? There are lots of good journals which publish review articles every year alongside the other articles they publish. There are also reviews-only journals. I'll give you some examples that we publish. We have a journal from the Indian Institute of Science, IISc, which is entirely reviews. We have nature reviews in multiple disciplines. Yeah. So similarly, there are hundreds of review journals out there which publish expert review commentary on a particular field. Cite those review articles instead of attempting to write a review of your own every time. Also, please remember to cite only what you read. If you read paper A and it cites paper B, you will cite paper A, not paper B. Okay? Because what you have, you don't know exactly what paper B says if you have not read it. What you are reading is the interpretation of author A of what paper B says. So you have to report it as such. Okay? Now, also at the end of the introduction, you have to be very clear about the specific aims of the paper. There is a problem in the field, how are you going to solve it, and exactly what is reported in this paper. Now remember, in the study design slide also we saw aims of the study. The aims of the study might be different from the aims of a single paper. What you do over 5 or 6 or 10 years, depending on your project funding, etc., is not going to be all reported in one paper. What are you reporting in this paper? What are the aims of that particular intent? Not the whole study that you're going to do with the DST project for 10 years. Yeah? So that's also very important. Because otherwise what happens, you list some aims and there is a disagreement between your aims and the final results that you show. Okay, so the aims seem to promise something very big, but the results don't actually meet that promise. That's because you're actually citing the aims of your entire project, which will probably run for a few years. Right? You have to cite the aims of this particular part of the study that you're reporting in the paper. Okay? I'm not going to go into detail with these slides. Let's move on to methods. In the method section, it's very important to report as much detail as you can because researchers needed to reproduce your work, and you must have seen also cases where reproducibility is a problem. Papers are retracted because they will not reproduce. So reproducibility is key. So you have to make sure that you give your methodology in enough detail that people can reproduce your findings and also build on the research. Also, it helps peer reviewers validate the work that you're doing. Whether your results are the correct outcome for the methodology you're reporting or not. So it's important to report methods in as much detail as possible. What do you report? Everything from samples or, I don't know, data sets, simulations, anything that you're using in your studies, tools and technology, hardware, software, how did you evaluate the data, what operations did you run on it, mathematical tools and tests, if any. Yeah, all of that has to be reported. Then I'm going to just try this with the example slide. Try to break down the method section into little subheadings. What this does, it makes it easier for you to write and it makes it easier for the reader to read. Now, you see here an example. This is from a biomedicine paper, yeah? A molecular medicine paper. You don't have to understand what it's saying, but I just want you to see. This is one of my favorites. It's from one of the Nature journals. It's quite old, but it's one of my favorite examples to show because it's so well structured. They report the samples and the equipment that they have used. In the second paragraph, they talk about one methodology, then they'll be using two. One methodology, describe it completely. Then they describe the second methodology completely. And then they talk about how they analyze the results. In this case, using a statistical test, but you could be using software tools or any other kind of analytical tools. Yeah? Then for results, the most important thing is to understand that results also need to be broken down into parts in the way that you report in a single study you will have multiple results about it, right? The most important results should be reported first and then in decreasing order of importance. Each result needs to be broken down broadly into these three elements. The initial observation you have, how you characterize that observation, and how does it apply to the research hypothesis? Okay? How are you solving the problem? So for an experimental setup, for example, I have an example here. Let's say we design a new membrane for water treatment, and he's evaluated the physical and chemical properties of this membrane under different temperatures and pressures. And we found that the efficacy of the membrane in removing particulate contamination is 75%. So you talk about what you did, what you found, how does it, interpret, and how does it apply to the problem at hand. And let's see the results example from the same paper that I just showed you the methods example of. Again, breaking down in little paragraphs really helps, and they report by mapping the results to each of the methods that they used. Okay? So they report the results out of the first method, then they report the results out of the second method, then they combine the observations from the two and the final analysis they did using the statistical test. Now I want you to focus for a second on the second paragraph here. You don't need to understand what it's saying, but you see there are figure numbers mentioned. We have highlighted them in color for you. And you see that the figure numbers are there, but there is no description of the figures. Yeah? So where does the description go? It goes into figure caption. Okay? All figures and tables in a research article must have detailed captions. Okay? Everything about that figure or that table must be described in the caption, because this is complex data that we're looking at in terms of research articles, and people need to be able to understand what's happening in the figure or the table without having to scroll up and down or flip back and forth. Okay? And this is again a great example. It's from the same paper, by the way. It's a great example because they also have some abbreviations used in the table, and they list also the exact description of the abbreviation as a footnote to the table itself. Yeah? Just to make it very clear to read at first glance. I also like this example from another paper. This I like to show because there is one key element here which you may not see at first glance. This is noise spectra data in 3 different directions. Yeah? It is basically the same kind of data. The authors could have, and most would have, mapped it onto a single figure with different line types or color types. But that makes it very confusing to read and makes the whole thing like hodgepodge. Yeah? By taking a few extra minutes to separate out the panels into 3 parts, they make it easier for everyone to read and analyze the data. So these little small things really, really count. Okay? Now we come to the discussion section. As I said, often it is non-existent. When it does exist, it is not always complete. I have also heard that it is the most difficult section to write. This we have heard repeatedly from our author surveys, and also when I do these workshops, I often do a board. So today we didn't have a lot of time. But would you agree? Is it the most difficult section for you to write?
Yes.
How many say yes? Great. So why is it so difficult? Because everything hangs here. Okay? It is the ending of your story. It is the climax of the movie. Okay? It is the degree that you want. It's the end of everything and culmination of everything. And what happens? Often people just get scared and just leave it out. Yeah? Or misinterpret what goes into it. It's very important to tell a story, and this finishes your story. If you leave it out, you're not finishing the story. How many of you sometimes read a paper from somebody, usually a native speaker of English, and you're like, wow, I wish I could write like this. They're not doing anything, out there. They're just finishing the story. Okay? So it's very important to complete our story, and we have already gathered all the elements. Now I want you to stop taking pictures. I want you to stop taking notes. I just want you to look at me and listen to me. You don't have to look at me. You just have to listen to what I'm saying. I'm going to give you an extempore example of how to write a discussion section. I'm just going to speak it out. I'm going to use the example of the water treatment membrane that I just showed you. Okay? So let's start. So how do we start? We start with what the first box here says.
Summarize what you did. What
There
you
is still
did.
some mumbling and whispers going on. Either I talk or you talk. You choose. Thank you. So we start with summarizing the research problem. What was the research problem? Let me explain it to you. The research problem was we wanted to design a new membrane for water treatment to replace currently used commercially available membranes which have to be imported to treat the run of water from fields in the arid regions of western Rajasthan and Gujarat. And the currently used membranes are expensive. They are also not very useful in the arid climates. They are not made for these climates. So we designed a new membrane using a local sustainable rubber-based polymer and simple 3D printing techniques. These membranes can be printed at the district level and easily replaced as required even in remote areas. Okay? We characterize the membrane's performance at different temperatures, pressures, and in different humidity conditions. And we found that the membrane lasts 50% longer than the currently used commercially available membranes. Okay? And it costs 50% less to manufacture. The efficacy of the membrane in removing particulate contamination is 75%. The change in efficacy and performance with temperature, pressure, etc. is shown in figures X, Y, Z. Okay? Which we don't need to repeat here because it's a discussion. If you have already done that in the results section, but if you really want to emphasize it, you can again repeat that. That's my first box. Okay? The efficacy of the membrane in removing particulate contamination is 75%. Now we come to the second box. However, the currently used commercially available membranes have an efficacy of 95% in removing particulate contamination from water. And the water filtered through these membranes can be directly used for drinking and potable use. Yeah. The water filtered from the membrane we have designed is not suitable for drinking. It is suitable for all other household uses, but for drinking purposes, it will need a secondary filtration system. Okay? What did we do here? We found limitations and we explained them. Okay? So even with the limitations, the work we have done still has a lot of value. But if you were to hide the limitations, that becomes a problem. Yeah? There is a case, I don't have that slide here, but there was a case where somebody hid some data points for no reason. For no reason at all. The results were still the same, only to beautify the graph. Yeah? So you see sometimes you get a graph with a lot of data points, and some points are like scattered here and there. They don't really affect the result. Your core theme is and trend is still the same, but they remove those outlier points just to clean up the graph. And this was published in one of the big journals, and the professor did it, and one of the students didn't like it. After the paper was published, he went and blowed the whistle and said, "We did this, and I'm not comfortable with it." That paper was not retracted because their results were still valid. All they did was like beautify the graph. But there was a correction published with a detailed description of what they did, which was iron. So you don't hide any sort of limitations. Okay? So it's very important to identify the limitations and clearly explain them. If I said, okay, the efficacy is 75%, great, let's just, start supplying this water treatment membrane to all the villages in India, great. And people can just use it for drinking water. It would probably make a lot of people sick if it were to get through. But before that, it will be stopped by reviewers. Yeah? Reviewer will come back, reviewer 2 will always come back to you. Do you read PhD comics?
Yes.
So reviewer 2 will always come back to you and say, hold on, you're comparing your product to that product. That product has an efficacy of 95%. Your product has an efficacy of 75%. How are you comparing them? Yeah? So it's very important to highlight the limitation. Now let's come to the final and concluding parts of this discussion section. What is our main conclusion? We have successfully designed and implemented a new membrane using a sustainable local rubber-based polymer and simple 3D printers. Okay? This can make it very easy for district offices to supply the 3D printed membranes from the district level to even remote areas. The membranes cost 50% less than what is currently in use. And they last 50% longer. The efficacy of the membrane is 75%, which is not enough to create drinking water, but a secondary filtration system can easily solve this problem. Okay. You can also talk about future work. For example, I would say we are working on improving the efficacy of the membrane. Okay. Or we are working on designing a secondary filtration system so that we can create drinking water. But telling the story, the full story, yeah, it's very important. So you have to tell the truth. There is no swearing ceremony, but it's still, you have to tell the truth, the whole truth, and nothing but the truth. It's just like doing science is just like doing law. Yeah? And with that, I'm going to end. I just want to show you one more slide. You remember I said 2 slides today. If you take nothing else back, take 2 slides back. This is the second slide. This tells you how to link ideas together to tell the full story. And completing the story is very important because nobody likes to be hanging. Yeah? Nobody wants to go on what is that thing called? Now the second movie of animals. Right? Nobody likes an open end, nobody likes a cliffhanger. You need to close the story. And it's most important in research publishing. And I want to draw your attention lastly to the 3 arrows on the right hand side, the 3 curved arrows. They talk about the linkages between the sections. It's very important to link your objectives to a problem in the field. If the problem is not described and you have some vague objectives, it doesn't make sense to anyone when they read your paper. The results should link back to the objectives you have defined. That's why I said it's very important that the objectives or the aims should be the aims of this paper, not of the whole project that you're running. Yeah? For example, I could be running with my I could be running a whole project on using this rubber-based polymer and 3D printers to create new innovative solutions for rural areas. So if I went in with the aim that I'm going to design a water treatment membrane, and then in the results I'm reporting, I use this rubber-based polymer to print and 3D printer to print bicycle tires, and they're great on rural roads. Makes no sense, right? There's disagreement between my aims and my results. Finally, the implications for the field should link back to the problem in the field. You talk about a problem, you have to talk about how you solve it. Yeah, how you solved it, didn't solve it, or partially solved it. You have to link these together. So, with that, I'm going to end. I'm going to let you ask some questions for maybe 5 minutes, and then we can finish. So, I finished in 45 minutes. Alright, so if there are any questions, you can ask about anything related to research publishing. Doesn't have to be what was discussed today.
question আছে জিজ্ঞেস করো।
Okay, there are no questions.
So for this
My-
is not for research
My,
articles. So for,
my,
no, I don't need.
you don't, you can just.
You don't need a mic, just project your.
So it's not particularly for research articles, but for review articles. So is the structure for the review article kind of same for like the research article?
What's your name?
Shorodipta.
Shobita, I have a question back for you. Now, as a research scholar, when you want to read a review article to get information about the state of knowledge of a field, you have two articles in front of you. One was written by a research scholar like you, and the other was written by an expert with 30 years of expertise in the field. Which paper would you read?
The research article one.
The one by the expert,
Yes.
right?
Yes.
So please don't write review articles. Okay? So you don't need to know the structure. When you get to the stage when you write review articles, you already know the structure. Write literature review for your thesis. And for that, you know there is a lot of detail that goes in there. A review article is similarly structured or sometimes completely unstructured. But review articles, ideally, in my personal opinion, should be written by experts. Because only then they hold value. Right?
Thank you so much.
You have a question?
Yes, I have heard at times that some people or professors sometimes they say that your English is not quite scientific. Now, I really don't know what do they mean by that. I mean, I just really wanted to ask how the language should be. Should it be very lucidly written, anyone can understand, or should be like very heavy and
Again, a question back.
Yeah.
What do you want to
yeah, so I would prefer the lucid ones. No, so now when a person like me would write a paper for the work, so I'll write it just like very lucidly. Now, if I say that not the grammatical parts, but the sentence constructions are not very good, and that type of comments do also come. So that is
So, language, of course, this is not your first language.
yeah.
Yeah, it's not probably for many of you, it's not even your second or third language. Yeah, you speak like 4 Indian languages or something else before you speak English. Right? So, it's perfectly understandable. If there are comments on linguistic structure, there are lots of tools to edit your linguistic structure. But those tools should only be used for language. As I said, that's a 1-hour presentation on why those tools should not be used for anything else, which we can do at another time. 2, writing in very, very complex language is not suggested for research publishing. Okay? At the same time, writing in literary language is also not suggested. So if your sentence structures are not crisp, or they use unnecessary synonyms or words. How many of you had Reverend Martin in an English course in your very good? Do you still have it?
Yes.
Yeah, burden. So it's very important to write scientific research papers are not to be written like theses or essays. Research papers have to be written in the right tone to convey your message to a global audience. Okay? Now imagine sometimes when we write, don't you feel that you are writing in English, but your sentence structures are coming out in your mother tongue? Yeah? Very, very famous saying in India, we are like this only. Yeah? It comes because your brain is subconsciously translating when you speak or writing. So now imagine if your sentence structures are too complex or too reflective of what is the structure in your mother tongue. Now imagine a student in China, Mongolia, Africa, Spain, whose English is actually worsening. They don't have as much exposure. How will they understand and interpret? So that's why crisp, simple, structured language. One very easy way to hack it is write in active voice. Okay? Methods typically are written in passive voice, but everything else you should write in active voice. Okay? Active voice and passive voice. Do I need to teach you that?
No.
So Reverend Martin will do that. So it's very important. Active voice is advice. Some journals might tell you not to use first person singular. So even if you're an author alone, they might tell you don't use the first person singular. So instead of I, write
We.
yeah, then you feel like the queen. So, any other questions? Yeah.
Should we use, there are many paraphrasing, rephrasing kind of apps. There are also AI apps which are available online. So whenever we are writing, should we take
The
help
help
from
of-
those?
As long as it's only to correct the grammar. Don't use AI to paraphrase because you've copied stuff from somewhere and now you're trying to get rid of the evidence.
Just to check the grammars and all?
Yeah, you can use it. There are built-in tools now. Microsoft Word, the grammar check that it does, it's AI support. So if you have Copilot enabled, it's actually going to do the grammar check, which is AI support. But only the grammar check. Okay? I don't really have the time to get into the pitfalls of what generative AI can do if you misuse it. So let's not get there. But yeah. Anything else that you have questions about? Yeah.
I just wanted to ask about something. Suppose we have a topic where it has been widely researched in the Western world, but it is relatively new in the Indian context or in the Asian context as well. So how would we start doing the literature review, or how do we start our basic research, like to identify our research problems and whatnot? What would be the ideal structure or the methodology to proceed in that way?
Okay. Firstly, it depends very much on the field. Okay. Two, I am definitely not an expert in all the fields. So the ideal person to ask that question would be your guide or somebody senior in the field.
Yeah, but suppose it is rather technical. So if I start my research, first I'll do some interviews. If I do interviews, like should I ask experts in the field to identify my research problem? Like would it be acceptable in the paper that I would write in the future? That I have.
You can ask anyone to help you identify. It's part of the job of your supervisor to help you identify a research problem, right? So you need to ask someone who's experienced in the field. I can't comment on a question generically, a question like that. It's very specific to what you're working on. Yeah. All right. Yeah.
It's a small technical question. In the methodology part, in the slide there was in the bracket, regarding the chemicals, where did you buy? Was written. Like why or how is it relevant? Like what do you mean by where?
Okay. So where you bought them, where you bought your tools and technology.
Samples, the chemicals.
The chemicals for treatment, yeah, that they use in biology labs. Where matters because sometimes the composition of where you bought them and where they were manufactured it changes. Water changes things. How a particular factory manufactures things changes things. Yeah, which batch was it changes things in the composition of the chemistry.
If I write the catalog number of the product along with the brand name, will that suffice or place of origin like USA, India?
Yeah, you should. If you're talking about things that are manufactured in a factory, you should list the place of origin and the batch number. Yeah, where they change. So if you're talking about chemicals, for example, I don't know, hydrochloric acid. Where was it manufactured? Okay.
Who writes that?
Ideally, you should. Okay. Of course, hydrochloric acid is a very basic example, but sometimes you have more complex chemicals, yeah, which are not always manufactured everywhere. Also, many journals look for ethically sourced. So, is the stuff you're using is ethical? So, as I said, hydrochloric acid is a very common example, but sometimes you have very specific chemicals. Where are they coming from? What is the source? What is the origin? So that's why they ask you to put country of origin. Yeah, if it's ethically sourced, if it is ethically manufactured, sometimes journals are also looking for that. Yeah. Last question.
In the research section, so we need to just mention our findings. Something maybe not comparable or maybe not so significant in between some groups. That also can be written in the result section. But
Yes.
when we will write the discussion section, we should conclude all our results together.
Altogether, the most important results and compare what sometimes when you are writing the results section, you also report results that are not directly relevant to the particular problem you are discussing in this paper. Yeah, you still report them. They might become relevant to something else later.
Reporting is the result section.
Result section. Discussion is analyzing the results in respect of the problem you were trying to solve and any other studies that have been done if there is comparative work.
And that's how we should conclude ourselves.
Yes. Yes.
Thank you.
Thank you.
For studying. Actually, this will help our students or as this is for, from behind where, HWWP, 024 is now for you. So, thank you. So, this is the end of the session. Now, we have to go to the Mukta Manchu for the other, the lecture and debate about and the releasing of the book. So, please, everybody, go here.